Good evening, everyone. I request all of you, those who are present, to post your names in the chat box so that we can know who all are present. I request all of you to please post your name so that I can know who all are present. Thank you. So Kirtana is here. Ronak is here. Ananya is here. So I have a lot of requests. Sushant is here. Okay, I'm waiting for 1 or 2 minutes more, guys, so that everyone can join in, and then I'll start. Is my voice clear to all of you? Is my voice clear to all of you? Okay, thank you, Ronak. Okay, Shomik is also here now. Okay, so the agenda for today's class is I have not done few topics in modern physics, so I'll complete that. Before that, I would be discussing about one topic, which is, let me just go through the doubts that you have posted to me individually. So a lot of doubts have been asked about optical instruments. So I will go through a few questions of optical instruments. Like, I will cover compound microscope for you, and then there are 2-3 questions which I need to solve from human eye. Though I already took a class of human eye on the other day, perhaps on Tuesday or Monday or Tuesday. But still, I'll take a question from human eye also. So before I'll start modern physics, I'll be covering human eye and the other optical instruments, such as, I'll take one compound microscope and the others would be similar. You can have a look at that. So I think a lot of people have joined, nearly 15-16 people have joined. So now let me start with the topic. So guys, I have already, those who have not attended my human eye class can go to YouTube Centum Academy page, and you can search for. Okay, Aditya is saying that we they don't have compound microscopes. Is it right, all of you? Is compound microscope is not there in your syllabus? Yeah, few people told me that it's there. So Aditya, please check. I think it is there in your syllabus because 3 or 4 people have told me that compound microscope is there in your syllabus. So I'm starting with questions, guys. Now, give me a moment. So, generally, if you look at this, just give me a moment, guys. So if I make something like this and you have human eye, so what happens is that you have ciliary muscle here, and this ciliary muscle is known for adjusting the focal length. Focal length, so that your image can always be formed at this retina. I'm not discussing parts of eyes. You can just go through the book. I'm just discussing image formation, and I'll solve a few questions for you all so that we can quickly skip through it. I have already done a lot of questions on this, and I'll take questions from NCRT book so that this topic can be covered properly. So, ciliary muscle is known for adjusting the focal length so that the image can be formed on retina. Now what happens, you will have there are two different concept. One is of least distance of distinct vision, and what is this least distance of distinct vision? Generally for a normal eye this is 25 centimeter. So what do I mean by least distance of distinct vision? So this is the minimum distance at which any object can be seen distinctly without any strain to your eyes. What do I mean by strain to eyes? What I mean by strain to eyes is that beyond 25 centimeter or below 25 centimeter, you have to just squeeze your eyes to see something. Now what happens is that if you have any eye defect, this least distance of vision gets changed. So in few of them this will change to 50 centimeter, 100 centimeter, depending on the type of defect that is there in your eye. So I'll cover up questions depending on change in least distance. The second concept is of far point, and infinite is taken as far point. So two things you have to always remember. If somebody is asking about least distance of distinct vision, for normal eye it is 25 centimeter. So if in a question you have been given least distance of distinct vision less than more than 25 centimeters somewhere, you have to understand that the person has certain eye defect and we need to use certain kind of glass. What kind of glass? So I'm discussing two distinct kind of, I'm discussing two distinct kind of eye defects. First one is myopia or short-sightedness. So always remember it. As soon as we listen to the name short-sightedness, we feel like he can't look at something which is very nearby, but it is exactly opposite. As soon as word short-sightedness come, look at this word short and try to understand that he can see something which is very near to him, but he cannot be able to see something which is very far from that place. So why does it happen? So if you have this human eye, what happens is that here is your ciliary muscle which adjusts the focal length, but the gap, this gap between the retina and the lens which is here is increased. So in myopia, the distance between the lens which is present here and the retina where the image is formed is increased. So what happens? Try to understand. I am writing the formula. This formula is not there in any book. I am trying to explain myopia with the help of formula of the lens. Please try to understand how this happens. The formula of the lens is 1 by v minus 1 by u is equal to 1 by f. Now what happens if I write this formula with the sign convention, as the image object is somewhere here and the ray is going something like this, and I am measuring the distance in the opposite direction, I will take u as positive. So 1 by v plus 1 by u is equal to 1 by f. Now what happens? 1 by v is equal to 1 by f minus 1 by u. Now what do I need to do? See, if this has increased in myopia, if the distance between the lens and the retina has increased, it means that the image is getting formed before the retina. Now if I use any particular lens, in this case we use concave lens. Why do we use concave lens? So try to understand. My objective is that when the image is getting formed before the retina, with the help of this concave lens, I should be able to refocus this image on the retina. So what has been happening? Finally my image is getting formed at v1 distance, and I have to increase it to retina. It means that I have to increase v1 to v2. It means that v2 which is at retina should be greater than v1 where it is actually getting formed. So what is happening? I have to increase actually this v. If this v is increasing, then 1 by v will go down. If 1 by v go down, then look on the left hand side. What happens? If 1 by v goes down and it is equal to 1 by f minus 1 by u, that particular thing will go down. So this particular thing should go down. For this to go down, as this f is constant because of the ciliary muscle, finally 1 by u should be increased. 1 by u increase means u should be decreased. So what is the meaning? If a person is not able to view something which is at very far distance, my objective is that with the help of a concave lens, I should make another image of that particular object with the help of the lens so that I can see it properly. So see what happens if this is the human eye. Once again, let me go to the next page. Look at here. If this is the human eye and what is happening, V is getting formed here. I have a concave lens here. Now what happens if this concave lens is not here? Anything which is at far point, suppose at infinite here, suppose here. So if this concave lens is not here, this from here it will go and image will be formed here. What happens if I apply this concave lens here? Due to this concave lens, something which is coming from infinite will, the image will get formed over here like this. The image will get formed something like this. So this is the new position of the image. The object is present here, but due to the concave lens, this particular concave lens will make an image here. Now this image will act as new image for, this image will act as, one second guys, this particular image will act as new image for my eye lens. So what happens, the object which was here, which was acting at, which was very far from my eye lens, now I have made a new image with the help of concave lens, and this new image will act as an object for my eye lens at the distance. Initially the u was this, now for my eye the u has been this. As I have reduced the u, so in the formula 1 by v divided by 1 by f minus 1 by u has been reduced. So this particular thing would be reduced and this will reduce. It means that v will increase. So that is what happened. Why do we use concave lens here? We use concave lens to reduce the distance of the object from the lens of human eye. Now let me take a question, let me explain you hypermetropia or long sightedness, then I'll move to the questions. So now look at here. In hypermetropia what happens? In hypermetropia what happens is that, suppose this is human lens, suppose this is human eye and this is the lens. Now what happens, the image is getting formed. In hypermetropia means long sightedness. It means that a person can see something which is at very far, but person cannot see which is very nearby to him. Why does this happen? Because instead of the image getting formed at retina, it is getting formed at a point far beyond retina. So it means that the v has increased. Now I have to reduce. So suppose this is v1, I have to bring this v1 to v2 where v2 is less than v1. Again I will write the formula for you. 1 by v is equal to 1 by f minus 1 by u. Now v has to reduce. It means that 1 by v has to increase. 1 by v to increase, 1 by u should be reduced. If 1 by u reduces, it means that u increases. So finally you have to increase u. To increase u, what should be done? We use convex lens here. So if we use convex lens, what kind of thing, what kind of just give me a moment. So what kind of ray diagram can be formed? Suppose it is going like this. From here, the u for the human eye would be at some far point so that it can locate it. Are you understanding this process? So in that scenario what will happen, so I have to make u greater, which I have already explained it to you. Now let me quickly take one or two questions which can be solved for you all. Just let me go to any numerical. Okay, one question which I can find in NCRT book is that a person needs a lens of power minus 5.5 diopter for correcting his distant vision. For correcting his near vision, he needs a lens of 1.5 diopter. What is the focal length? So all of you know that when you know the power, you can find out the focal length. How can you find out the focal length? What is the formula? Always remember, P is equal to 1 by F, and this F is in meters. Many of you get it wrong. I have given this question in the examination also. You write F in centimeters and come out of the examination hall, which should not happen, guys, please. So please remember these formulas very properly, where you have to keep meter, where you have to keep centimeters, so that you don't make silly mistakes in the exam. Now, if power is equal to 1 by F, and so F would be equal to 1 by P, and there are two P's given. One is minus 5.5, so here you keep minus 5.5, or the second P which has been given is 1.5, so you keep 1 divided by 1.5, you will find the answer. So this is how you have to move ahead in this question. Next question in this section would be this: the far point of a myopic person is 80 centimeter in front of his eyes. What is the nature and the power of the lens required to correct the problem? Now try to understand what kind of person he is. Person is myopic. If person is myopic, his far point is how much? Far point is 80 centimeter. How much should be the far point? The far point should be, so let's understand this question by this. So finally what happens, if I use a concave lens, the concave lens, what will concave lens do? The concave lens will increase the U from human eye. For normal human eye, what is the far point? Infinite. Here, what is the far point? 80 centimeter. So finally what happens is that whatever is present at U, whatever is present at infinite, because for normal eye far point is infinite. If a person cannot see something which is at infinite, or which is, let's not say infinite, which is at very long distance, because his far point has reduced to 80 centimeter, whatever is at very long distance, the image of that particular object with the help of concave lens should be made at 80 centimeter. It means that if I write this formula, which is 1 by V minus 1 by U is equal to 1 by F, I am taking U far point is equal to infinite for a normal eye. V here should be how much? 80 centimeters. So try to understand. Let me write it for you. And V should be positive or negative? V should be negative, because the image would be formed on this side. So guys, always remember, in case of concave lens, V would be negative here. So 1 divided by 1 minus 80 minus 1 by infinite, which should also be negative, but as it is infinite, I am not writing anything, should be equal to 1 by F. So 1 by F should be equal to 1 divided by minus 80, or you will find out F is equal to minus 80 centimeters, or minus 0.8 centimeters. So always remember, when far point has increased, when far point has decreased from infinite to 80 centimeter, U would be infinite. For normal eye, V should be whatever far point that has been given in the question. Now V should be kept as negative, because we are using concave lens. Hence the image that would be formed would be on the left hand side of the concave lens, which is opposite to the direction of movement of rays, or direction of ray. That's why V has to be taken negative. If V would be taken negative, the value of F would be negative, and value of F can be represented like this. So this is how you have to solve the question. Now it has been asked, what is the power? You already know power is equal to 1 by F, so 1 divided by minus 0.8. So somewhere if you see power to be negative, and if somebody is asking you what kind of lens the person is using, your answer should be concave lens. So if power is coming out to be negative, you are using concave lens. So 1 divided by minus 0.8 is equal to minus 1.25 diopter. And look at here, all of you, I'm repeating once again, I'm not keeping 80 centimeters here, I'm keeping zero point 0.8 meters here. As simple as that. Did you all understand this question? Any doubt in this question? Can anyone, if you have doubt, you can ask me. Any doubt in the question? No doubt. Okay, fine. So I'm moving ahead with another question. Okay, next question is, I'm just taking a part of the question. The near point of a person is 1 meter. I'm just going to a different page. Near point of a person is suffering from hypermetropia. What has happened in hypermetropia or long sightedness? Person can see something which is far beyond, person cannot see something which is near to that person. So it means that the concept that we were discussing, that least distance of distinct vision, so that increases, which is also called near point. So near point, which is 25 centimeter for a normal eye, for this person, I'm writing normal eye here, for this particular person, near point is equal to 1 meter. Now, what kind of lens would be needed? So as soon as you see that the eye is he's I'm sorry, he is suffering from hypermetropia, so you should tell the type of lens, which would be convex lens. Why convex lens would be needed? Because we need to increase the value of u. To increase the value of u, you need a convex lens there. Now try to understand. Let me apply the concept of lens formula here. 1 by v minus 1 by u is equal to 1 by f. So what should be u? Try to understand. I have to, if near point has increased, what I need to do is that I need to readjust the near point at 25 centimeter. It means that the image formed by convex lens should be at 25 centimeter from the human lens of the human eye. And what is the v? Wherever the object is, whatever is the new whatever is the actual near point of the eye, so which is 1 meter here, so I am keeping over here 1 by minus 100 minus 1 by minus 25 is equal to 1 by f. So how much it is? It can be written as 1 by f is equal to 1 by 25 minus 1 by 100, which is equal to 4 minus 1 divided by 100, or 100, sorry, 3 divided by 100. So f comes out to be, I am writing on the top, 100 by 3 centimeters, or I have to find power, so I am writing 1 by 3 meter. So power would be how much? 1 by f, which is equal to 1 divided by 1 divided by 3, which is equal to 3 diopters. So that is how you can solve question. I have solved questions based on myopia, I have solved question based on hypermetropia. Now I don't think you should have any doubt in case of questions related to human eye. If there is anything, you can post it now. I will try to clarify all the doubts, if any. So Shomik is asking, sir, is shouldn't it be positive? So I can understand, Shomik, you are asking that shouldn't we be positive. Now try to understand. Look at uh, Shomik, okay. Okay, I'll explain once more. Few people are asking, can I explain once more? Give me some time, guys. One second, try to understand. Let me just give me a moment, guys. Let me remove, let me make some space. I cannot go beyond this page. So, okay, let me use a new color now. I'm bored of blue color. Which color is good? Okay, green color. Okay, guys, look at here. Let me make a convex. This is suppose human eye. All of you, please focus why V would be negative. I am explaining that. Let me suppose this is human eye. Suppose my near point should be here, which is at 25 centimeter. Now what happens? The near point has gone to 1 meter. To correct it, what do? I put a convex lens here. Now let me explain the formula once again to you. In hypermetropia, where the near point increases, why it increases? Because instead of image being formed on retina, it is formed beyond retina. So what happens? Actually the V should be this much. Suppose this is V1, the V increases to V2. Now with the help of this lens, I need to decrease the V. It means that this V1 should be lesser than V2. It means that whatever V is getting formed by the naked eye or the eye without lens, I have to decrease that V. Now what happens if this V it decreases? Then what will happen? 1 by V will increase. Now try to understand. 1 by V is equal to 1 by F minus 1 by U. So if 1 by V is increasing, this right hand side should also increase. Now this 1 by F is fixed by your ciliary muscle. So what happens is that for this to increase, 1 by U should reduce. If this reduces and this is fixed, this complete value, which is 1 by F minus 1 by U, will increase. If 1 by U should decrease, then in that case U should increase. Now try to understand, all of you, why V is negative. Now suppose an object has been kept here. Now what happens? This U is already negative here. Look where the image is getting formed. Image is not getting formed after, on the right hand side of the convex lens, so that you will take V as positive. The image from this convex lens is getting formed somewhere at far beyond point here, so that you can increase the value of U. So image for the human lens is getting formed away from the actual object, which is my objective, which is on the left hand side of this convex lens. That is why I take, as V is not getting formed on the right hand, V is not getting formed here, I'm crossing here, V is getting formed here, I mean image is getting formed here, I'm sorry, V is not this, V is this, image is getting formed on the left hand side of the convex lens. That is why V has to be negative in this case, not positive. So all of you, still if you have any doubt why I took V negative, give me, ping me in the chat box. Otherwise what I'll do, I'll move ahead. So in this question, what happened? 1 by V minus 1 by U is equal to 1 by F. Now what happens? What should be the value of U? Anything which should be 25 centimeter for normal eye. As the near point has changed to 100 centimeter, now everything should go to 100 centimeter. So 1 minus 100 and 1 minus minus 25. That's what I did. So Shamik is saying it's okay. Anyone? Do you guys, Ronak, do you find it? Ronak, Mansi, three people asked me this doubt. Is this okay from all of you guys? After this, I'll start. After this, I'll start something else. Okay, guys, nobody is saying anything. I'm removing this then. Okay, so now guys, I'm moving to modern physics, and in the end I'll come to this again optical instrument, because a lot of people are asking me for modern physics. So let me explain you a few concepts of modern physics. So as you all remember, I have already discussed with you all the concept of electric discharge. What was electric discharge? The concept of electric discharge was that under normal circumstance, the gas would not, circumstance means under ordinary pressure, the gases would not conduct electricity. So for gas to conduct electricity, we have to create very high potential. Now what happens if I am able to create a very high potential across? So I have created this kind of, one second, I had created this kind of, for cathode ray tube, I've created this kind of arrangement. So this was my anode, and there was a DC source here, and there was an emitter here, and there was an anode here, and this was a vacuum valve, and you had a pressure gauge here, and this was your anode, and this is your cathode. Now what happens is that when the gas pressure is lowered, it is found that the gases can conduct electricity at sufficiently high potential. So in this particular case, with the help of this DC source, we would increase the, this is my DC source, and we will try to increase the potential difference across higher V, I am writing here, higher potential difference between anode at cathode. What happens quickly, I'll wrap up through it. What happens is that when you keep on decreasing the pressure, there comes a pressure and a particular potential difference. When this anode, which is opposite to cathode, suddenly this particular tube would be dark at certain very small pressure, which is pressure I am writing 0.01 mm Hg. At this small pressure and very high potential difference, suddenly the tube will become dark. And what will happen? From here, you will see certain kind of lights uh, coming out and making this anode illuminated. So what happens is that a light comes from here, this becomes dark, and this becomes get illuminated. This particular phenomenon of of flow of free electrons, later it was found by a scientist called J.J. Thomson, that the particles which are coming out of cathode are nothing but electrons. This was found by a scientist called J.J. Thomson, and he gave E by M ratio. So what are the different properties of cathode rays? Try to understand, as first of all they are electrons. They would be, as they are electrons, they would be deflected in electric and magnetic field. Also, as they have very high energy, when they collide with some particle, some uh, I mean, if they're traveling through a medium, they'll collide with particle which are not charged, and they'll make them ionized because of their energy, whatever energy they contain. Now, cathode ray, this is very important. They travel in straight line. This is very important, and usage of this would be done when I discuss X-ray with you, this will be very important. Cathode ray travel in straight line. Also, they affect photographic plate. So all these things are very important. You just go through it, all of you. These are not things which where any particular concept is required or something like that. So I'll start X-ray for you. X-ray is usage of cathode ray. What happens is that there was a scientist called Roentgen. So when he was discussing cathode rays, what he found is that, so when he was discussing when he was studying cathode ray, what he found that there was a screen kept over, there was a screen kept near to the cathode ray experiment tube, and when this cathode rays striked with this screen, try to understand, the screen was coated with barium salt. I'm again writing, the handwriting was not good. Barium salt. Now what happened? He was astonished to see that why this screen was glowing when the cathode ray tube was active. Whenever cathode ray tube was active, this screen was glowing. Whenever cathode ray tube was not active, this screen was not glowing. What he did, he finally coated it, or he finally wrapped it with black paper. Even if black paper was wrapped on it, this screen was glowing. It signifies, or it tells that whatever ray was going from that cathode ray tube was able to cross this black paper and strike with this barium coated screen, and finally this screen was glowing. So what he did, he finally Guys, can you hear me now? Can you hear me now? Can you hear me now? Okay, fine. There was some disruption in internet. Because of that, it happened. Now let me start with production of X-rays. So production of X-rays, you don't have to study much. You just open. I'm not making diagram for this. Try to understand. The diagram is already there in your book, Pearson book. That's why I told that keep it with you. I hope all of you have it. Uh, so X-rays, the complete arrangement of production of X-ray, that particular tube is called Cooley's tube. In that Cooley's tube, you have a filament you see in your book that has been represented by F, and you have a target. Target is made of tungsten. Now, what happens is that filament is heated, and electron is produced from there, which acts as a cathode ray for this particular experiment. When this electron with very high energy is stopped by, always remember that X-ray is produced when the cathode ray, the electrons of the cathode ray is stopped by a target. So when this high energy electrons are stopped by the target made of tungsten, the X-ray is produced. Now what happens, you look at there in the diagram in your book, the target is made like this. Guys, look at here, the target is made like this. Why the target is made like this? Why target is not a straight particular thing so that it strikes here? So why target is inclined at 45 degree? The target is inclined by 45 degree so that when this cathode ray will strike, the emission of X-ray would not be in direction of the cathode ray, so that it goes and strikes with the electron comings, and we can find out the maximum intensity of the X-ray outside the tube. That is why I'm sorry, this is made at 45 degrees so that the X-ray comes out and we can find out the maximum intensity of the X-ray out. Now what are the properties of the X-ray? Properties of the X-ray is, first of all, it is electromagnetic radiation. If it is electromagnetic radiation, we all can know that the speed of the X-ray would be the speed of the light, which is 3 into 10 to the power 8 meter per second. Now X-ray is not made of electron, proton or something charged particle. As it is not made of charged particle, it will not be affected by electric and magnetic field. Also, we all know that it affects photographic plate. We know its uses, that it affects photographic plate. That is why they are used in medical field for X-rays and all. So this is what guys, I'm not going beyond your book this time as I usually do it in the class, because I'm just doing revision for you guys, and I'm trying to cover as much as possible. Obviously, I'll take one and a half more class to go in when I start engaging classes in your school, so that I can go beyond your Pearson book. Today, my objective is to only cover Pearson book and your textbook, NCRT or whatever it is. Now, let me move to radioactivity. So before I move to radioactivity, and I'll teach all these things very properly for next half an hour. So please focus on this thing, guys. Let me just. Okay, so what is radioactivity? Okay, Somik, try to understand. There are different kind of. So what about photons? Photons are also electromagnetic waves, but are they affected by electric and magnetic fields? So you can understand wave nature and particle nature of electromagnetic waves. So if you understand it with particle nature of electromagnetic waves, uh, uh, what if you you just correlate the X-ray for the time being with the particle nature of electromagnetic waves. So if you understand it with particle nature of electromagnetic waves, guys, can you hear me now? Guys, can you hear me now? Okay, fine. So perhaps I have answered that question. Now let me move to radioactivity. So what is radioactivity? So before I explain radioactivity to you, let me explain you two things. One is atomic number. And what is atomic number? Number of protons present in the nucleus is known as atomic number. What is mass number? The mass number is number of protons plus number of neutrons. So if I know these two things, what happens is that we can go and study we can study radioactivity. What do we mean by radioactivity? So guys, try to understand. uh, Radioactivity activity means self disintegration. What do I mean by self disintegration? So the naturally what happens, the larger molecules or larger, sorry, larger nucleus of atomic numbers more than 82, what happens, because they have huge size. Try to understand, guys, this is not there in the book, I'm trying to understand. We have proton plus neutron here, and we have electron around it, roaming around it. Now what happens, why neutrons are present here? Presence of neutrons is to balance the proton. Now what happens, as the number of proton increases, if I have equivalent increase in number of neutrons, what happens is that the size of the nucleus will increase unproportionately. Hence, with the increase in the number of proton, in subsequent increase in number of neutron is not possible, and that is why the complete nucleus plus this atom becomes highly unstable. It becomes highly unstable, and because it is highly unstable because of its size and very high p by n ratio and all, this gets disintegrated. So self disintegration of any particular atom because of its size and imbalance in proton to neutron ratio, that is called radioactivity. So there were two three scientists like Becquerel, and he discovered it, then Madame Curie and Pierre Curie, both of them started reading about it. How it was found out, how scientists came to know that radioactivity is present. So what happened is that there was a uranium atom kept somewhere, and there were photographic plates, and those photographic plates were fogged whenever it was kept near the uranium atom. Initially they thought that some kind of ray is getting it is getting generated from the uranium atom, and it is striking this particular photographic plate. So it was called Becquerel rays at that point of time. Later it was found that atoms get disintegrated because of the regions I have already discussed with you. Now what happens when atom get disintegrated? What kind of radiations comes out? So there are three kind of radiations which come out. The first kind of radiation is alpha radiation. Now alpha radiation is actually ionized helium atom. So what happens is that, how it was found that what kind of radiations comes out? So there were three kind of radiations, and when they were allowed to pass when they were allowed to pass through electric field, few of them deflected towards negative plate. It means which particular radiations will deflect towards negative plate? The radiations which were positively charged will deflect towards negative plate. The radiations which were negatively charged will get to deflected towards positively charged plate. And there would be few of them, or there were few of them which did not deflect at all. So alpha rays are positive helium item. So how do you represent helium item? 2He4, and you have two positive because they have lost electrons, so there would be two positive on it. How do you represent beta? So beta is represented like this: -1 B0. You can call it +2 here also. And gamma rays would be something like this. So that is how you represent alpha, beta, and gamma. Now what happens? What happens when alpha decay happens? So try to understand. Whenever alpha radiation would be there, suppose this is the parent atom. So whenever alpha decay will happen, atomic number, this is nothing but atomic number Z. Don't think that I have written there, so that is atomic number. Z is atomic number. Atomic number will decrease by 2. Why? Because helium atom is coming out, which atomic number is 2. So 2 is going to this helium atom. So hence for parent atom this would be Z minus 2, and mass number will decrease by 4, and you will have a positively charged alpha particle. As simple as that. Here P is called parent number, and D is called, or parent nucleus, D is called daughter nucleus. Now in case of beta emission, what happens? In case of beta emission, the atomic number will increase by 1 because electron is, this is minus 1 beta 0. So your mass number remains same in case of beta emission, and your atomic number increases by 1. One thing which has been explained in your book is that how beta emission happens. So your book says that the presence of excess neutrons in an unstable nucleus lead to neutron changing into proton by emitting an electron. Try to understand what is happening. Extra neutrons, extra neutrons, they change to proton. So if a positive, I'm sorry, they'll change to proton. If a positively created charge, if a if a positive charge is getting created here, there and neutron is neutral, so there should be an equivalent creation of negative charge, and that is what your beta ray is. As simple as that. So whenever a negative charge would get, a proton will get created or neutron will change into proton, there would be emission of a beta particle from there, which is nothing but in form of electron. And then you have emission. What do you mean by gamma emission? In gamma emission, there is no change in atomic number, there is no change in mass number. Shomik, the doubt created by you, that is alpha decay and decay accompanied by heat. I will discuss it when I am discussing the other concept of radioactivity, which is artificial transmutation. So when I discuss artificial transmutation, your doubt will be taken care of. So please wait for 5 minutes. Your doubt will automatically go. Now try to understand. In case of gamma emission, there is no change in atomic number and mass number, but there should be some change. What is that change? So with gamma emission, there is a change in energy of the nucleus. So with gamma emission, what changes? Energy changes of nucleus energy gets changes. With beta emission, the atomic number will go by plus 1. With alpha emission, the atomic number will go down by 2 and the mass number will go down by 4. In beta emission, the mass number will remain same. So guys, please remember all these things. Now let me move to, so there is also one concept of radioactive series. So I will explain it in 2 to 3 lines, nothing more than that. Radioactive series. So what do I mean by radioactive series? Radioactive series means what happens whenever an unstable atom is there and it is self disintegrating. So that parent nucleus will get converted into a daughter nucleus. Now what happens is that it is not necessary that the daughter nucleus also would be stable. The daughter nucleus can also be unstable. If daughter nucleus is also unstable, then daughter nucleus will also get disintegrated and will convert into new daughter nucleus. If that new daughter nucleus is also unstable, again that self disintegration will keep on going on. So all the uranium series which is there in your book, if you look at the radioactive series, is resultant of the fact that after disintegration, whatever the after alpha radiation, beta radiation or gamma radiation, whatever the new nucleus have been formed, that nucleus is also radioactive, and that is why it is getting converted into new daughter nucleus, and that is what is called radioactive series. Now after radioactive series, there is nothing more in radioactive series. You don't need to muck up whatever that has been given there. Let me move to law of radioactive disintegration. So law of radioactive disintegration. What is the law of radioactive disintegration says? So law of radioactive disintegration says that in any radioactive substance, the number of nuclei getting disintegrated per second is directly proportional to the number of nuclei present. What does it mean? So our equation has been given. Try to understand. Dn by dt is equal to or is proportional to n. So what happens? Try to understand. Whenever this n is, I mean, try to understand when it is 1 kg and when it is half kg. There are two scenarios. What happens? When it is 1 kg, this is high. Hence, the rate of disintegration per second or rate of disintegration would be high. When the amount of the nucleus present decreases, the rate of the disintegration also decreases. That is what it has been told there. Now, if you integrate it, n comes out to be n naught E minus lambda by T. What is lambda? Lambda is known as decay constant. So try to understand what happens whenever lambda will increase. What will happen? Higher value of lambda means more disintegration. Higher value of T means more disintegration. So this formula, you should remember it. I don't think you will get a question on this formula, but you should remember this. Now, what is this value n? Is this the value which has already been disintegrated, or is this the value which is left out? Always remember n is the value which is left out, not disintegrated. The disintegrated value would be n is equal to nuclei which is left out. Guys, this is very important. So if somebody asks you that then how much has been disintegrated, so initial value was n0 minus n would be equal to the amount which has already been disintegrated. Fine. So you should remember like that. So please remember this formula. You should know that n0 is the initial amount of nuclei, lambda is decay constant, T is the time taken for disintegration, n is the remaining amount which is present left out right now, and disintegrated value would be n0 minus n. Now I am moving to a very important concept which can be there in your exam, which is half period, half life period. Now what do you mean by half life period? Time taken by a nuclei to disintegrate itself to the half amount of the initial value, the time taken by the radioactive substance to disintegrate itself to the half amount of initial value is known as half life period. So try to understand. If initial value is if initial value is equal to n0, so half half life period would be, guys, I'm sorry, half life period would be equal to the time taken for n0 to become n naught, n0 to become n0 divided by 2. This is the half life period. Now let me take a question for you. So question is, if 7/8 of the initial mass of radioactive substance decays in 15 days, what is the half-life period of the radioactive substance? I will again read the question. This is from your Pearson book. First question in the concept of half-life period. So the question is, seven-eighth of the initial mass of the radioactive substance decay in 15 days. What is the half-life period? Try to understand. If initial mass is equal to m naught, decay is how much? 7/8 by m0. Now try to understand. Left out amount would be how much? M naught minus 7 by 8 m naught, which is equal to m naught by 8. So now I can use this in case of formula. So what happens is that, how do you use this formula? So try to understand. They have given a half-life formula. So half-life formula is like this: m is equal to m naught 1 by 2 to the power mu, where mu is equal to t divided by t. What is t? T given time period. And what is capital T? It is half-life period. Now try to understand how this formula has been originated. That is there in your book. I'm not getting into derivation of this. This is very simple. Please go through chapter 9, page number 13 or 14 in your book. It would be there. So guys, please understand, whenever you have to find out half-life, you have to use this formula where m again is the left out amount, m naught is initial amount, 1 by 2 to the power mu, where mu is small t divided by capital T. Small t is nothing but the given time period. Capital T is nothing but the half-life period. So try to understand. Here I'll put the value. M naught by 8 is equal to m naught 1 by 2 to the power 15 divided by t. Given time period, small t is 3. So 1 by 8 is equal to m naught will get cancelled. 1 by 2 to the power 15 divided by 3. I should know that this is 1 by 8 and this is 1 by 2. So this power should be 3. So I am directly writing 15 by t to be equal to 3, or t comes out to be 15 divided by 3. That is equal to 5 days. As simple as that. So guys, did you understand this particular uh, thing, half-life thing? Now I'll close the session in next 15-20 minutes after explaining a few more things. So if you are not understanding anything, please be conscious of that and please ask as quickly as possible. Next 20 minutes I'll wrap up the session. Okay, somebody is asking me. No, okay, I'm sorry, the clock here is not okay. We have enough time left out, guys. Some good 40 minutes are there. I'm sorry, I thought it's 7:10, but it's 6:45 only. We have half an hour. Don't worry. The watch in front of me was fast, so I thought it's 7:10 already. Any doubt, guys? Okay, fine. Fine. Let me do another question for you. The next question is 20 gram of radioactive substance decays to 10 gram in 2 days. How much of the substance will remain undecayed after 10 days? Guys, try to understand. 20 gram is becoming 10 gram in how many days? 2 days. Good. Why this information has been given? This information has been given to tell you that the half-life period is 2 days. As simple as that. Now, what is the formula? M is equal to M naught 1 by 2 mu, which is equal to M naught 1 by 2 T divided by T. As simple as that. Now try to understand, this T has been given as 10 days. Capital T, which is half-life period, I know this is 2. So it has been asked that after 10 days, how much amount would be undecayed, left out. So try to understand, this is 20 grams 1 by 2 to the power 10 divided by 2, which is equal to 20 1 by 2 to the power 5, which is equal to 20 divided by 1 by 32, or this is nothing but 5 divided by 8, which comes out to be 0.625 grams. So these are the two questions based on radioactivity which has been there in your book. I have solved both of them. If you have any doubt, you can ask me, otherwise I'll move ahead. People have started leaving the session. So are they not interested or they know everything? Okay. Now let me move to something called isotope, isobar, and isotone. So isotope is nothing but where you have same atomic number. So like 1H1, 1H2, 1H3. Atomic number is, if Z is same. If Z is same, then what happens? That would be called isotope. After that, what is isobar? So try to understand, isobar means same mass number. So same mass number means what? Same mass number means A is same. So when Z is same, it is isotope. When A is same, it is isobar. And the third one is isotone. So remember guys, the second last word is tone N. So it means that same neutrons. So always remember, people get confused in tope, tone, all these things. Tope means here it is P, Z is same, it means number of protons are same. So if P is there, number of protons same means Z same. If N is there, isotone, N is there, it means that same neutrons. And the third one is anyway isobar. Isobar means A is same. As simple as that. So after this, let me move to artificial. How many people have a height less than, let's say, 4 feet 8 inches? This area. So this is what this chart is showing you. So this chart is a normalized chart. It is equality with the height. Let me move to the another important concept of artificial transmutation. What do you mean by artificial transmutation? Artificial transmutation means, I told you in the beginning that radioactivity was only found in atoms which were of Z greater than 82. As simple as that. Atomic number greater than 82. But it was found that, and this was found at none other than Rutherford. So he found that even lighter elements can show property of radioactivity. And how? So that is the property of lighter element to show radioactivity in presence of external stimulation is known as artificial transmutation. What do you mean by artificial transmutation? So it's the process of transforming one element into another by artificial disintegration. What do I mean by artificial disintegration? So something like nitrogen. Now nitrogen at its own can is is not a radioactive substance, but whenever a nitrogen is bombarded with alpha particle, it gets converted to oxygen and it releases a proton. So such kind of change, so try to understand, Shomik. Now when alpha particle is going and striking with neutron, it is striking the neutron with very high energy when it is getting bombarded. So how that energy is getting transformed, it may be due to heat also. So that amount of high energy of heat may be required. If that high amount of heat is present, it may happen, as simple as that. So or that high amount of energy is there, because if alpha particle is going and striking with the nitrogen target, it is striking with very high energy and getting converted into oxygen and proton, as simple as that. So artificial transmutation is nothing but with external stimulation converting the smaller particles, smaller atoms into different atoms and release of a proton or neutron or electron, anything, and plus a large amount of energy from there, as simple as that. Now let me move to nuclear energy. What do you mean by nuclear energy? Guys, give me 1 minute. Let me 1 minute, guys. I'll drink water and come. Give me 1 minute. So you can do both. So but since it's your use first what you can accept like through SAS or through the for the MIT and this question is how much time should you spend? It was to confuse. That is one side. Okay, guys. So, what is nuclear energy? So, nuclear energy. Let's discuss it quickly. So, a lot of concepts are used in nuclear energy. First concept which is used in nuclear energy is artificial transmutation. Second concept is used, which are decay, splitting of, or you can say split of large nucleus into smaller nucleus. The third concept which is used in nuclear energy is change of energy leads to change in mass, or change of mass leads to change in energy, which is E is equal to delta mc square, as simple as that. Before I explain you these things, one thing you should know, that is atomic mass. What do you mean by atomic mass? So atomic mass is nothing but, so atomic mass is defined as mass of an atom is measured in units called as, this is for measuring mass of an atom. And how do you measure mass of an atom? So there is a reference value for that. And that reference value is 1/12 of mass of a neutral carbon. As simple as that. So reference value for measuring mass of an atom is 1/12 of mass of a neutral carbon. This is known as 1U. This is depicted as 1U, and this is nothing but 1.66 into 10 to the power minus 27 kgs. So it is like that. So mass of carbon would be how much? 12U, because I'm taking 1/12 of mass of a neutral carbon. So mass of carbon atom would be how much? 12U. Now let me estimate. Now what happens? There is another concept given, which is mass defect. So what is mass defect? Let me explain you what is mass defect. So let's take an helium atom. So in helium atom, what happens is that in helium atom, there are two protons. So mass would be 2 into 1.0078 units, and there are two neutrons also. So mass would be 2 into 1.0087 unit. If you add the complete mass, that comes out to be 4.0330 unit. This should be the mass when calculated with the help of atomic mass. But what is the actual mass? The actual mass is actual mass of the helium atom is 4.0026 unit. If you find out the difference of this, that would come out to be nearly 0.3004 units. Now question is, actually if you add the mass of proton and neutron, this much should be the actual mass or atomic mass, but the atomic mass or the actual mass is 4.0026, and this amount of mass is lost. This amount of mass which is lost is known as mass defect. So mass defect is nothing but difference between the sum of individual mass of the constituents of the nucleus. So whatever is the individual mass, sum of individual mass of constituent of the nucleus, which is proton and neutron. So find out mass of each proton, find out mass of each neutron, add it. Whatever this particular mass is, difference of this mass from the actual mass of the nucleus will be known as mass defect. So if this is the mass defect, it means that there is change of some kind of mass. So how energy Einstein mass energy equivalence is used here? Try to understand. There are 2-3 questions which the scientists wanted to answer. One question was that in the nucleus so many positive protons are there. So if positively charged protons are there in the nucleus, there would be repulsive forces acting between the present protons in the nucleus. Still, they are bound in certain region. They are not going beyond this nucleus. What is the reason behind that? Second thought, what is the role of neutrons in the nucleus? So there comes the concept of mass defect. Later, it was understood that the electrostatic force and the gravitational force acting between the electrostatic force between the protons and the gravitational force acting between proton and neutron, all these combination of all these forces will have lesser effect than the nuclear force which is acting inside it. And what do you mean by nuclear force, and from where nuclear force is generated? So later it was understood that when protons and neutrons inside the nucleus are combined, the change in the mass, which is this mass defect, is converted into energy. And the change of this mass, which is converted into energy, is known as nuclear force, which binds protons and neutrons inside the nucleus, and it overcomes the electrostatic forces working inside the nucleus, plus combination of your gravitational force and electrostatic force. So that's how this change in mass is converted into energy. E is equal to delta mc square. This change in energy is nothing but your nuclear energy, which is, or nuclear force, which combines these protons and neutrons together. So that is how we have to understand the concept of mass defect. How mass defect, the energy is generated, that energy is able to hold the protons and neutrons together, and it is able to overcome the energy, the negative energy created due to the repulsive forces of the positively charged protons inside the nucleus. And that is why nucleus is bound under the certain dimension even if repulsive forces are working. As simple as that. Now next concept is binding energy. So what is binding energy? So binding energy is nothing but the nucleons of the nucleus are bound together by energy that results from the loss in the total mass of nucleons, which is mass defect. This energy is known as binding energy. So as simple as that, whatever I was discussing till now, that due to mass defect energy is created, that energy is able to bind the nucleus into certain dimension to, and it overcomes the repulsive forces also. That energy is known as your binding energy. Formula is given. Binding energy per nucleon means average energy required to extract one nucleon from the nucleus. So binding energy, one nucleon means binding energy divided by the mass number. Sorry, yes, mass number A. Nucleon means your proton and electron both. So A means P plus N. So add P plus N. It works on complete nucleon. So it should not be Z, it should be A. Both proton and neutron are included here. So that is the concept of binding energy per nucleon. Now let me move to nuclear fission. After that, I will go to the last concept of today, which is your compound microscope, and then I'll wrap up the class. Guys, if you have any doubt till now, you can ask. I give you 30 seconds to think. If you have any doubt, you can ask. Any doubt, guys? Okay, nobody is replying. Fine. Okay, let me move to nuclear reactions. So I'm going to teach you nuclear fission. Nuclear fusion, you can do it on your own. So nuclear fission. What do you mean by fission reaction? So fission reaction is nothing but, suppose um, an unstable radioactive substance is there. Suppose uranium 235, 238, anything you can take. And suppose a neutron goes and collides there. Now this particular uranium atom will get disintegrated into a lighter nucleus, where A would be equal to anywhere from 85 to 104, and a heavier nucleus as compared to this, but lighter than this, heavier nucleus, where A is equal to 132, 149. And what else would come? More number of electrons will come. So if one electron is striking it, you will see at least on an average 2.5 neutrons coming from here. As simple as that. So this is nothing but your nuclear fission. Is nuclear fission there in the syllabus? Nuclear fusion, sorry. Can anyone reply, please? Are you guys not able to hear me? Okay. Mansi, is nuclear fission and fusion there in the syllabus? Okay, fine. So if nuclear fission is there, I am explaining nuclear fission to you guys. So more number of electrons will come. Now what happens? Try to understand. This neutron which is striking should be moving slowly. This is one property. Fast moving neutrons cannot produce nuclear fission. On an average, you will see 2.5 neutrons getting produced. I have already told you that there would be two nucleuses. One is heavier nucleus, and there would be second higher nuclear. Another byproduct of nuclear fission is gamma rays. So always remember that this gamma rays is produced whenever nuclear fission is going on, and that is why this nuclear fission is very very dangerous to the living organism because of production of gamma rays. And gamma rays can extensive exposure to gamma rays can be fatal to human life or living organisms. So that is the thing. Now, one of the important thing which has been given in the book is that, let me explain it to you. Is effect of mass defect in case of nuclear fission. So guys, try to understand. Suppose I have uranium 235. I write it, and suppose it is struck by a neutron. So what happens? I'm sorry. Krypton 3692 plus barium 56 141 plus 3 neutrons comes out of it, and a lot of energy is generated. As simple as that. Now, if you look at mass of this side and mass of this side, what happens? Mass of this is nothing but mass of this is 235.124 unit. Mass of neutron is 1.009 unit. Mass of this is 91.94 units, and mass of, I'm trying to explain mass defect here, guys. Try to understand. This is 140.948 units, as simple as that. So and you add 3 neutrons, there would be mass defect. If you calculate the mass of both sides, there would be mass defect of 0.214 units, and due to this mass defect, a large amount of energy would be produced here. So what that would be, 1 unit produces 1 unit of if atomic mass of 1 unit is there, and that is the amount of mass defect, 931.5 mega electron volt energy is produced. So with this, how much energy would produce? 0.214 into 931.5, which is equal to nearly 200 mega electron volt. Now guys, try to understand 1 mega electron volt. You might be understanding joule properly rather than mega electron volt. It's 1.6 into 10 to the power minus 13 joule. So if I convert it into joule, this would be nothing but 3.2 into 10 to the power minus 11 joule. So due to one uranium atom, this amount of energy is produced. You can understand, if I take enriched uranium of 5 kg or maybe 100 kg or 200 kgs, what kind of energy would be produced. That is why nuclear bombs are so destructive. One, they produce gamma rays, and huge amount of energy is produced, and which is converted into heat. If I give you a live example, year 1998 1999 saw rapid increase in temperature in areas such as Rajasthan, Punjab, Western UP, even Eastern UP, Delhi, all these places. What was the region? 5 nuclear explosions by India and 6 nuclear explosions in nearby area by Pakistan. And you can understand the amount of heat generated during those explosions, which led to a lot of increase in the temperature in those areas at that point of time. Temperature first time reached nearly 50 degrees Celsius in those areas. So those are the practical importance of these concepts. Now let me move to the last concept of the day, which is compound microscope. And I have a PDF for that. I'll send that PDF to you guys on the group also. So what is compound microscope? Guys, try to understand here. So I hope the screen is visible to you. Compound microscope is used when we need very high when very higher magnification is required. So in that we use two convex lenses. So you look at here, I'm pointing at the screen. this particular convex lens is known as objective, and this particular convex lens is known as earpiece. Now what happens is that this is my object, suppose. So this particular object, I keep the aperture and the focal length of the objective very very small. Why I keep it small? So that the object is placed beyond the focal length. If object is placed beyond the focal length, the image formed by this objective convex lens would be real, inverted and magnified. If it is real, inverted and magnified, then we have this eyepiece. Eyepiece means, suppose this is the region, this region, look at the cursor on the board, this is the region where my eye is placed. What happens is that in front of the eyes I have this convex lens which is called eyepiece. Now aperture and focal length of this eyepiece is kept very very high. So if aperture and aperture and focal length of this eyepiece is kept very very high, what happens? The image of this objective is formed which is under the focal length of this eyepiece. And as this is this the distance of this image formed by objective will work as object for eyepiece. And as the distance of the object and the eyepiece is less than the focal length, the image formed would be virtual, highly magnified and on the left hand side. So this is the final image which is formed, which is virtual and highly magnified. So what happens in this sense is that as this is here, which is u is less than f, and if I is here, to eyes it will seem that the rays are coming from somewhere here, and that is why the image has been formed here, and that's why we will find very highly magnified image in this sense, as simple as that. So this kind of arrangement is used for compound microscope. Now a derivation has been given over here. Go through the derivation, though it will not be used. Just remember the formula which has been given in your book. If you will remember the formula, I think that should work for you. The magnification m. If try to understand guys, if two convex lenses are there, suppose this is one convex lens which is my objective, and suppose this is my eyepiece. So what happens is that there would be one magnification by this, which suppose I called MO, and there would be one magnification by this, which suppose I called ME. So final magnification would be equal to MO into ME, as simple as that. And that would be equal to, you see, you just find out the terms which has been given in your book. That would be equal to L by FO multiplied by D by FE. FO and FE, you know that this is the focal length of objective, this is the focal length of eyepiece. What are L and O? L is the distance between L is equal to distance between the two lenses. And what is D? So suppose if final image is getting formed here, so D is the distance between eyepiece and final image. So just remember this. I'll share that PDF file with you guys. So this is all from my side for today's class. If you have any doubt left out now, you can post your doubts. in the chat box. Otherwise, we will wrap up. So I'm waiting for your doubts. If there is any doubt, you can ask me. Any doubt, guys? So I'm not getting any particular doubt from anyone. So what I do is that I'll wrap up the session. We have covered a lot. We have covered complete modern physics. If there is any doubt that you guys have before your examination, any time before your examination, I'm always there to help you out, all of you. You can, I'm just a call away from you guys. You can send me a text, you can call me directly, any point of time. I would be there to help you out. Thank you so much, all of you, for attending the class. I hope the class was beneficial for you guys. And in case of any doubt, revert to me. Thank you. Thank you so much. Okay, guys, thank you.